Microplastics in the ocean by Helen, Landon Jurek, Bo Wallace. The problem. Microplastics in the ocean have affected marine organisms through their toxic properties. This review examines how microplastics form in the ocean environment, primarily through weathering of plastics on beaches, which breaks down the material into microparticles carried into the water by wind or waves. Unlike natural particles, microplastics attract persistent organic pollutants at a much higher rate due to their surface properties. Marine organisms may ingest these pollutants along with microplastics, but the full extent of their transfer across different levels of the food web and the consequent ecosystem damage remain uncertain. Given the escalating ocean plastic pollution, it is crucial to further investigate these microplastics' impact on marine ecosystems. Why are microplastics bad? Microplastics can harm both organisms and ecosystems alone because of their ingestion. This review examines how microplastics found all over the place in marine environments consist of various polymers and additives capable of absorbing substances like nutrients and pollutants from their surroundings. Their small size enables ingestion by a wide variety of marine organisms, posing significant risks. Beyond direct harm, microplastics also concentrate environmental contaminants, transferring them through food chains and potentially impacting ecological processes. Recognized as emerging pollutants, microplastics pose a substantial threat to marine biodiversity globally. This summary outlines the effects of plastics and microplastics on marine organisms and ecosystems.
So this is a graph that describes how the number of microplastics in the ocean has been growing throughout the years. Solution 1. In order to reduce the amount of microplastics found in the ocean, we first need to reduce the amount of plastics produced and consumed. This means that we need to be aware of what we are using and consuming, as the more that we consume, the more that the companies will produce. And this is known as supply and demand. This includes reducing, reusing, and recycling, and using compostable items like paper plates and paper straws. This is shown when researcher at Seoul National University of Science and Technology, W. Shim, states that lowering the amount of microplastics in the ocean can be achieved by reducing the amount of plastic produced and consuming less plastic products. This means that before we think of any fancy or technological ways of clearing up the ocean, we need to first reduce the amount of plastic products produced, whether it be with nationwide or state laws. But we also need to purchase and waste fewer plastic products, and this is how they are getting into the ocean. So the limitations and implications. One big limitation is that we all already have bad habits of wasting ingrained in us, and many of us need to learn how to be more aware. Some of these bad habits include purchasing and using too many plastic products and wasting them and throwing them away with close to no use. And also, using things like plastic water bottles and cling wrap are things that we may not even realize we're doing. And to back this up, or to give you a better all-around idea, here is a quote from the Executive Director of Global One Health Academy and Professor of Molecular Epidemiology, S. Thacker, which states that people waste plastic due to its superior properties and lack of manageability, which is leading to increased volume in the natural world and a global issue.
Solution 2. Microplastics already in the ocean have effects that can be reversed with multiple filtration solutions and absorption systems. Now, what are some forms of treatments? The first form of treatment is filtration systems. They've only been used for desalination, which is taking salt out of the ocean and using it for drinking water. And it uses a very fine film to filter out anything from the clean water and then dispose of. They have to be huge, as in dozens of plants all across the coast, and the plants are very expensive to build and to maintain year-round. Some absorption inventions include biodegradable sponges made of starch and gelatin, and they absorb about 90% of microplastics per unit of water. Unfortunately, they are purely preliminary because they've only been used in a controlled lab setting in an amount of water about the size of a pool. Javier Bio of the Department of Chemical and Environmental Engineering says, rapid sand filtration systems effectively reduce microplastics in urban wastewater treatment plants with higher removal efficiency for particulate forms. What he's saying is that we can use sand filtration systems, which is taking sand out of the ocean to make it clear water and more drinkable, and we can use that for microplastics. What are some limitations and implications of filtration and absorption systems? Unfortunately, there are several concerns with filtration and absorption. For example, desalination plants cost $32 billion to build and maintain year-round, and it would cost extra for microplastics because microplastics would need some disposal system to either burn them or just get rid of them somehow. We would need dozens of these $32 billion plants per every coast, and any testing on microplastics is preliminary. It's only been done with salt before in the ocean. Same with absorption. It's purely precursory, but if technologies are refined and mass-produced, change could be seen in the near future. According to the U.S. Government Survey School of Water Science, the primary reason we don't see more filtration plant is due to the cost to operate these plants. Energy consumption hikes up the cost of a plant. Like I said, it's $32 billion for just one plant, and that's not even counting a disposal system for microplastics.
So now we are brought to the comparison between solution 1 and solution 2. To review, solution 1 is the reducing of microplastic consumption, which eliminates plastics directly from the source. This stops manufacturers from creating plastic. Then solution 2 are filtration systems, which aid in eliminating microplastics currently in the ocean. So the better solution. We found that solution 1, which is reducing microplastics at the source, is more viable. In solution 1, plastic production can be replaced with biodegradable materials, which is already in action. However, in solution 2, the machinery required is expensive and the processes need extensive labor. To support this, according to the Australian government's Department of Climate Change, the simplest way to reduce plastic waste is to avoid unnecessary and single-use plastics, support businesses who are reducing plastic waste, and reuse existing plastic. In this quote, he is talking about eliminating plastics from the source because people slow the production down due to them not purchasing the plastic products, which overall eliminates plastic gradually over time. So this is our result.